this is going to be like your first page of the final. So the first question probably is going to be something with two fractions. And the best, quickest way I know of to do it is to cross multiply. So do the bottom of the right times the top of the left. So if you do that, you'll get x times x plus 4 on the top of the left side. And then take the bottom of the left side and multiply it times the top of the right side. So if you do that, you'll have the right side, which is x plus 6, multiplied by the bottom of the left side, which is 2 plus x. So you're going to start out by having x times x plus 4 equals x plus 6 times 2 plus x, like that. Then you're going to distribute the x. So x times x is x squared. And then x times 4 is 4x. And then distribute the next pair of parentheses. So x times 2 is 2x. And then x times x is x squared. And then 6 times 2 is 12. And then 6 times x is 6x. So that's how you're going to start. Then you're going to subtract an x squared from both sides to move it to the same side. And notice it actually cancels out on both sides. So sometimes on the final, there'll be things that make the problem a little bit easier for you, so it doesn't take as much time. Then what we have left is we have 4x equals 12 plus 6x, like that. So we have to subtract the 6x. And then you'll get negative 2x equals 12. And let me rewrite that again up here. Negative 2x equals 12. This is the other 12. The other 2x. Oh, I forgot about the other 2x. You're right. So I was making a huge mistake. Now, by the way, the final exam is so stressful, it's easy to make mistakes like this. So I forgot to add the 2x plus 6x. So what is 2x plus 6x actually? It actually should be 8x. So this 6x is actually wrong. So this is, let me change that 6 to an 8. There we go. So negative 2x, oops, wait a second though, but if I change that to an 8, I have to change that one to an 8. So 4x take away 8x equals what? Negative 4x. So I actually get negative 4x equals negative 4x equals 12. And so then that should be negative 4x equals 12. Does that look better? Now, what do I do to get x by itself at this point? Divide by negative 4, correct? And then you get x equals what?
Negative 3.
Negative 3, correct. And then, now the thing is, this is the answer, but believe it or not, they have very strict grading on the final. If you forget to write the restrictions on the original fractions, then they will only give you 3 points out of 4. And I'll have to only give you 3 points out of 4 on the final for this problem. So the reason is because this answer could be wrong, even though you did everything right. So you have to know that there's two values of x that cannot be, and you have to write those down as well. So look at the denominators. The denominator 2 plus x means that x cannot equal negative 2, right? And the denominator x plus 4 means x cannot equal, what could x not equal on that one? Negative 4. Because if x equals negative 4, then negative 4 plus 4 is 0, and you cannot divide by 0. So you have to write the two answers that it's not, for sure, not ever those answers, as well as the answer that it is as well. So that problem is now done. And then let's just go right ahead. And since I'm recording this, I can post this recording into Moodle as well. So then you can like fast forward and move the video back and forth if you need to watch something again. So I'm going to go ahead and go on to problem number 2. And I'm also going to paste a blank copy of this exam review in Moodle for you as well, so that you can print it out and practice it. I'd recommend that you do a dress rehearsal of the final and print out a blank copy and go into an empty room by yourself and see if you can do it all by yourself. And then you'll know that you'll be ready for the final if you can. So this next equation has a square on it. Oh, I'm sorry. This next equation has a square on it. So we need to take the square root of it to cancel out the square, right? We're going to take the square root. We're going to do the square root around both sides of that equation like that. And then the square root of 3x minus 5 squared crosses out the power of 2, right? So the only thing you're left with is 3x take away 5 equals square root of 32. However, though, the number 32 can be broken apart into two different numbers. What's the biggest number that goes into 32 besides 32? How about 16? So you can break it apart into 16 times 2, right? And then what's the square root of 16? 4. So that means 3x minus 5 equals, oh, and by the way, I almost forgot. What's the principle of square roots that we learned when you take the square root of a square? That's good. The left side is good. But the right side has to change to what? Positive and negative, right? So don't forget to put a positive or negative in front of the other square root after you cancel out the square. So in front of this square root, there needs to be a positive, a negative sign right there. So make sure you put that plus and minus in front of that. Now, what's the square root of 16? 4. So keep the plus and minus sign there and write 4 like that. So the square root of 16 is 4. So take that 4 and put it down with no square root anymore around it because you did the square root already of it. And then you need to move this negative 5 over to that side. And that makes the 5 and negative 5 become a positive 5, right? So you'll get 3x by itself equals positive 5 plus or minus 4 square root of 2. And now there's one more thing to do to get x by itself. What do you have to do now to get x by itself? Divide it by 3. So if I divide both sides by 3, I would get x by itself equals 5 plus or minus 4 square root of 2 all over 3, like that. X equals 5 plus or minus 4 square root of 2 all over 3, and then stop right there. That's the end of the problem. So that is fantastic, and we're done.
And on the final, will it have the button for plus or minus, or?
Well, it'll just be written. So like you're going to have an actual file. That's why I printed it out for you and made it be on paper.
We're gonna have
so you're going to have one that looks like this, and you'll just write on the piece of paper. And by the way, make sure that you show your work, because no matter how many times I tell every class that I teach, don't just write the answer down. If all you have is this answer, there may be some people who can do this all in their head and just write the answer down, but I can't give you credit more than 1 point for just the answer. The rest of the work has to come from showing your work. So even if you have all the answers right, you need to write like 3, 5, 7, -10, and like write all the answers down and nothing else. I could only give you 1 out of 4 points for each problem. And every problem on the final is going to be worth 4 points. So I can only give you full credit for all 4 if you get everything right. But if you get part of it right, I can give you partial credit. So I'm going to give you as much credit as I possibly can, but I still have to follow the guidelines for grading. So the next problem says to solve that. So our first step is to get it equal to 0 on one side. So it'll be 15x squared, and then that negative 14x moves to the left side, so it becomes positive 14x, and then negative 8 equals 0, right? Now I'm going to use that special factoring method that I taught you before. So first of all, you keep the 15 and you drop the square. So I'm going to write 15x, like that. And then so you keep the 15 where it is at first, but you drop the square. Then you bring down the sign that's before the middle term. So there's a plus sign, right? So bring down that plus sign. And then the next sign is negative. So draw an arrow between the plus and the minus. Who knows what a negative times a positive is? It's a negative. So that becomes a negative. Then draw another line from the 15 in front to the 8 at the end. So what is 15 times 8? And ignore the negative with the 8. We already put that down. What is 15 times 8? Actually, let me just write them down to the side. Ready? So 15 times 8. And our goal is to actually break that apart into something that equals 14. So if we wanted to, we could multiply it together, but we also could just break it apart. 15 is 3 times 5, and what is 8? 2 times 2 times 2, right? And then, let me think. What if I group the 3 in the middle, and the 2 in the end together. So what do the 3 numbers in the middle make? 5 times 2 times 2. What is that? Makes 20. And what does 3 times 2 make? 3 times 2, just 3 times 2. 6. What is the difference between 20 and 6? 14. It's a 14, correct. And you should put the biggest one first, because the biggest one should go with the same sign as the middle term. So the middle 5 times 2 times 2 was equal to 20, right? So put 20 first, and then 3 times 2 is 6, and that goes last. And the reason we chose 20 and 6 is because the difference between them equals 14. So you will be able to break apart those two numbers into 2 different groups. Now, sometimes you'll have to be creative and like group these middle 3 together and then group the outer 2 together. Sometimes you'll have to group the last 2 together with the first 3. You will just have to figure out a way, whatever way works, to group them into 2 groups so that one group multiplies together and the other group multiplies together. And the difference between them is, well, not necessarily the difference, but whenever you put the results of those 2 groups in with these signs, which happen to be different signs in this problem, then it should create the middle number. So that's what you do. Draw a line from the first number to the last number, break it apart into 2 groups, so that when you put those groups into these spots, it should add up to the middle number. And now we're still not quite done factoring it yet, because the 15 needs to be reduced. You can only reduce the 15 by the same amount the rest of the factor reduces by. So what number goes into 15 and 20 bills? 5. So that one has to be reduced by 5. The other 15 has to be reduced by a different amount. So what number divides both into 15 and 6? 3. So that one needs to be reduced by 3. So 15x plus 20, if you divide it by 5, it will only leave you with 3x plus 4. And 15x minus 6, if you divide it by 3, will only leave you with 5x minus 2. So we get 3x plus 4 times 5x minus 2 equals 0. Then to finish solving it, you just set each of those equal to 0. 3x plus 4 equals 0, and 5x minus 2 equals 0. So I'll move the 4 to the other side. 3x equals negative 4. Divide by 3, and you'll get x equals negative 4/3. And then the other one, if I move the negative 2 over, it becomes positive 2. Divide by 5, and you get x equals 2 over 5. So those are the 2 solutions, and you can circle those like that. Perfect. Now, the next question is actually very similar to the question number 2, except you're solving instead of having a square. So in problem number 2, you had a power of 2, which is called a square. Do you see that power of 2? In problem number 4, you have the opposite of a square, which is a square root. So our first step is to get the square root by itself. So we're going to move over the negative 4, which is right there. Move that negative 4 over. And then you get the square root of 2x plus 3 equals positive 4, like that. Now, to get rid of a square root, you have to use a square. So we're going to put both sides in parentheses and put a power of 2, which is called a square, on top. So that's called squaring both sides. So the square root of something squared crosses out the square root and the square. So you're just left with 2x plus 3. 2x plus 3. And the 4 squared is 16. Like that. So actually, this 2 means to remember, and 316 means John 3:16. I just noticed that. But anyway, though, the next step is to subtract 3 from both sides. So you get 2x equals 13. 2x equals 13. And then divide by 2. So you get x equals 13 over 2. Now this problem, though, isn't one of the problems that you can necessarily be sure about the answer with. So every time you solve an equation with something that has a restriction on its domain, such as a fraction with a denominator with an x in it, or a logarithm with an x in it, or a square root with an x in it, then you have to make sure the answer really works. So 13 over 2. Let's try to put that in. What is 13 over 2 times 2? 26 over 2, right? So where I put the question mark, I'm just going to check the answer real quick. If I plug in 13 over 2 for x, I'll get 26 over 2, right? So I'll get 26 over 2 plus 3 minus 4. And the minus 4 is outside the square root, but the 3 is inside the square root. So what is 26 over 2? 13. So that is 13 plus 3. What is 13 plus 3? And then what is square root of 16? And what is 4 take away 4? And what was the other side of the equation equal to? It was equal to 0 originally, right? So it checks that this equals 0. So then put a check mark beside this, and then put a box around the answer. What happens if you get the right answer, but it doesn't work though? Then you should still show this answer, but you should put an X beside it, and then draw a line through this to show that that didn't work. So most of the time it works. Maybe about 1 in every 5 to 7 finals has a problem that doesn't work. It's kind of random. So always make sure you check your answer if you're solving an equation that started with a square root, because there's always a chance that it won't work. Number 5. So this one, we have to get the absolute value by itself. So the first step is to subtract 2 from both sides. Boom, do that. And then what's 11 take away 2? 9. And then the absolute value of 3x minus 5 is what's left. And now the way to solve absolute value equations, first of all, you have to get them by themselves. And sometimes there's no solution. So how do you know if an absolute value equation has no solution? If the number on the right is negative. Yep, if the number on the right is negative, there's no solution. So that's the first thing, to make sure you get it by itself. And this is not negative, so there is a solution to it. So how do you find the solution once you know there is a solution? Well, remember we talked about this one time. If the absolute value of something is equal to a number like 9, there's two things that have an absolute value of 9. The absolute value of 9 is equal to 9. And the absolute value of negative 9 is also equal to positive 9. So the thing inside of it could be a 9, or it could be a negative 9 or whatever, right? So 3x, so that's all you have to do is just break it apart into those two halves. 3x minus 5 could equal 9, or 3x minus 5 could equal negative 9. So add 5 to all the equations. Add 5 to that equation. Add 5 to that equation. And then you get 3x equals 14. And get 3x equals, what's negative 9 plus 5? Negative 4. So 3x equals 14, 3x equals negative 4. Does that look correct? And then divide by 3. So x equals 14 over 3, and x equals negative 4 over 3. I'm skipping the step where I actually write down the divided by 3. But if you did divide by 3 on that side, the 3 would go away. If you divided by 3 on this side, you'd be left with 14 over 3. So that is the solutions to that equation. Boom. Okay. So let's see how much more we have to go. Let's go ahead and finish the first and second pages of the review today. Then we can do the third and fourth pages on Wednesday and the fifth and sixth pages on Friday. Then you can take the first 2 pages of the actual final exam on Monday. Do you think that will work for you? Because then you won't have to take it all at once. Because up until last fall was the first time I tried splitting it apart. My classes would still get pretty low scores on the final. But then I tried splitting it apart, and the scores went up a lot. The only people who didn't get good scores basically were just the people who never did the review at all. So make sure you work really, 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 really hard on this review. So then this equation. Who remembers how to find the center of a circle? It's the exact opposites as what? As the numbers that are with x and y inside of the squares. So what's the opposite of the number that's with x inside the square? So the x value of the center is negative 3. And what is the opposite of the value that is with the y inside of the square? Yep. So the center is therefore the opposite. So it's negative 3, positive 5. That's the x and y coordinates of the center of the circle. And how do you find the radius of the circle? By taking so that 25 is the radius squared, right? The original number in the equation is the radius squared. So what do you have to do to find the actual radius? Square root. Now, technically, every time you take the square root of a square, you have to make the other side become positive and negative. That's the rule of math. Except in this case, though, you can't have a negative size of a circle. So you're just going to drop the negative and just leave positive square root of 25. And what's the square root of 25? 5. So the final answer is r equals 5. Like that. Perfect. You excited? Do you feel better about the final now that you have a better idea what might be on it? Oh, yeah. Yeah. Go down. There we go. Is that good?
Yeah.
Perfect. So let's go to page 2. So this one jumps ahead to logarithms. So basically, we learned about logarithms. In order to solve this logarithm, we need to reduce one side of it to being a single logarithm. And the way we reduce logarithms to be a single logarithm is by looking at the factors inside and putting them together. So put together the x plus 4 together with the x minus 4. And then remember, whatever coefficient that the logarithms have is the power of the factors that you'll have when you put the factors together. So what coefficient is in front of the first logarithm? That's a 1, right? What coefficient is in front of the second logarithm? That's a 1 as well. So it's kind of hard to see because there's not much space, but let me make it bigger. So that's a 1 and that's a 1. So each of those factors needs to have a power of 1, 1, and 1. And I'm only writing that so in case the final has a number in front of it, like 2 log 3 of x plus 4 plus 3 log 3 of x minus 4, you would know that you'd put a 2 and a 3 on those powers. So here we go, we've got this. And then once you combine the factors together with the powers on them, then it makes it all into a single logarithm. So now instead of being separate, instead of being 1 log 3 and another log 3, it's all together with 1 log 3. And then equals 2. And then who remembers how to go on to the next step? So how do you get rid of the log 3 and make it be gone? Remember, this is the way where you have, so what base does the logarithm have? Has base 3. So you start with the equation 3 equals 3, right? But then you pretend like the previous equation, I'm actually going to save time by not writing it again. But you imagine that the previous equation is the power or the exponent of this. So let me move that 3 over to the left a little bit. Like that, 3 and 3. See that? So basically put those bases of 3 underneath to the left side and underneath the corner of the previous equation. So that's called what? Do you remember the name for that? Expo what? Exponentiation. So we're going to exponentiate the previous equation by putting the base 3 below it, right? And then what happens to the base 3 to the power of log base 3? Cancels. So we're just left at that. What happens to base 3 to the power of 2? What is 3 to the power of 2? 9. So the right side becomes 9. On the left side, it mostly goes away. The only thing left on the left side is just x plus 4 and x minus 4 to the power of 1. Except the power of 1 doesn't really matter that much because the power of 1 doesn't change anything at all. So now I'm going to multiply those parentheses together. By the way, one common mistake that happens at this point is some students will think, wait a minute, it's already factored, so I can just break the equation apart. So some students will try to do x plus 4 equals 9, x minus 4 equals 9. What's the problem with that?
It's not.
Because if x plus 4 and x minus 4 both equal 9, then that means that 9 times 9 equals 9. And what is 9 times 9? It's 81, it's not 9. So you can't break it apart unless there's 0 on the other side. So we have to go ahead and multiply those together. So x times x is x squared. X times negative 4 is negative 4x. 4 times x is 4x. And 4 times negative 4 is negative 16. So I did all that work. And one amazing thing happens. The final was really nice to us. And it let those things cancel out. So negative 4x plus 4x canceled out. And then you have 9 on this other side. So x squared equals 9. So then you have a square equal to a number. And we can use the same method we used on problem number 2 to get rid of the square. We can take the square root of both sides. Square root. Oh, you were right. Forgot about the 16, my fault. So I probably wouldn't even pass the final if I took it. So x squared minus 16 equals 9. So x squared minus 16, the 16 is actually left. So I have to move it over first. So I have to add 16 to the other side. Good thing that you stopped me. So I get x squared equals 25, right? Because 9 plus 16 is really 25. Now I can take the square root of both sides finally. The square root, and then you, on the left side, the x squared and the square root, they're opposites of each other, so they'll cancel each other out like that. So the square and the square root eliminate each other, but then whenever you do that, though, in a squared equation, you have to remember that the other side changes into a positive and a negative, like that. So x equals plus or minus square root of 25. What's the square root of 25? 5. So it's plus or minus 5. Now, remember I said the 3 things that have domain restrictions are square roots, denominators, and logarithms. So this equation has x inside of a logarithm at first. So we need to make sure that these 2 solutions are within the domain of the logarithm. So that, in fact, the number itself doesn't matter whether it's in the domain of the logarithm. It just matters whether the equation will result in something that's in the domain of the logarithm. So what is positive 5 plus 4? It's 9. And 9 is a positive number, and that is in the domain of the logarithm. But that's not enough, though. We have to make sure that the positive 5 is also in the domain of the other logarithm. So what does positive 5 take away 4? 1. And 1 is positive. So both of them are positive. So that means that positive 5 is in the domain of the equation. So that's a valid answer. But you have to be really, really careful, though, because guess what? This is not a valid answer just because the answer is positive. It's only valid because the logarithm had ended up with a positive inside of it. So if you would have had logarithm of x minus 6, for example, and you had the answer be 5, what does 5 take away 6? Negative 1. So that would have not been an answer. Even if the answer is positive 5, that doesn't guarantee that it's actually an answer. It only is an answer if it really makes both logarithms be positive on the inside. Now look at negative 5. Is negative 5 an answer or not? Well, try it out. Negative 5 plus 4, what's that? Negative 1. So you can't have a 0 and you can't have a negative in a logarithm. It's not possible. So that means that negative 5 isn't actually an answer at all. So only positive 5 is the real solution to that equation. So we're done with that. Any questions about that? And then let's go to number 8. And before I forget, let me check names again real quick. So, are you Pachua? Pachuca? Okay. And Andrew Jaden. Perfect. Perfect. All right. Okay, there we go. So now let's do the number line one. So the first step is to realize that this is 3 parts. The left part, the middle part, and the right part. So when I subtract 5 from the middle to get rid of the 5, I need to also subtract 5 from both of the other parts. So instead of just subtracting it from both sides, I have to subtract it from all the sides. So start out by subtracting 5. And then who knows what negative 1 take away 5 is? Yep, negative 6. And then less than or equal to a negative 2x over 3. And then plus 5 minus 5 is nothing, right? So we have nothing there. What's 11 take away 5? So we have 6 on that side. Now the next thing we need to get rid of is the fractions. So let's multiply everything by 3. Because remember, on the Very first day of class, we learned to get rid of fractions, you have to multiply by the common denominator. So the common denominator is 3. So we're going to put everything in parentheses, multiply everything times 3. Like that. And then 3 times -6 is -18. And then the 3 in the bottom of that, sure enough, it cancels out with that. So that fraction is now gone, and only the top of it is left. -2x. Less than 3 times 6 is 18. And then how do we get rid of a multiplied by -2? So right now, this is x times -2, because it's -2 times x. We'll have to divide by -2, right? So if we divide the whole equation by -2, we'll have to divide the other sides by -2 as well, by -2 too. So -18 over -2 is what? And then -2x divided by -2 leaves you with a positive x. And 18 divided by -2 leaves you with a -9. Now I haven't written the signs down. That's because of a special reason I want to emphasize. When you divide an inequality by a negative number, the inequality itself has to switch. So this left-hand sign becomes a greater than or equal to sign. So switch the directions if you ever divide an inequality by a negative number. So switch this to a greater than or equal to, switch this to a greater than sign. Like that. And then now x is by itself. So we solved it. So this is part 1, that's solving it. And then graphing the solution on a number line. So let's draw a number line like that. And let's put 9 onto it. Now what's weird is this actually is backwards because the smaller number is on the right. But that's fine though, that's just where the solution happens to be. But this is actually the littlest side. This is actually the biggest side. So put the littlest one first. So put the -9 first, and then put the +9. And then we're going to put a solid dot by which point? Which of these has an equal sign in it? No, +9 does. We're going to put a solid dot by the +9. So put a solid dot on that point, and then the other one doesn't have an equal sign with it. So it's going to be an open dot. Then we're going to, x is between them, because this basically says x is on the big side of -9, so it's bigger than -9, but x is on the little side of +9, so it's littler than +9, so it's below +9. So it is right between -9 and +9, and then we have graphed it, so that's the second answer. Now, one cool thing that I like about this particular final, I don't know if it'll happen next time or not, but this is a more old-fashioned final that doesn't say to use interval notation. Because my aunt actually told me they didn't even have interval notation when she was in math. At least she says that. I don't know if that's true or not. But so this is just a traditional solution. This is just a traditional number line. But just in case it asks us, how do you write this solution in interval notation? You write it from what it's between, which is -9 to 9, right? And then you put a parentheses where it does not touch. So it's an open circle means a parentheses. And then you put a bracket where it does touch. So a solid circle is equal to a bracket. But that's optional though. If it doesn't say to use interval notation, then you don't have to use it. But just in case it does, I'm going to show you what that means. There we go. Interval notation. Perfect. Now, number 9 is one of the questions that most people either get a 0 on it or they get like almost all of it correct. And then a few people just make a small mistake. So I want to make sure that you get everything correct because it'll help your grade a ton if you get like 100 on the final, because the final is worth tons of your grade, more than any other test and more than any other homework. So solve the system of equations. First of all, when you have systems of equations, you have to figure out which letter has the smallest common multiple. So what's the common multiple of 3x and 2x? It would be 6x. What's the smallest common multiple of 5y and 3y? It would be 15. So which is littler, 6 or 15? 6 is littler. So let's focus on the x first. And what I try to do is I try to get the top one to be positive common multiple the bottom to be negative common multiple. So what can I do to make the positive 3x on the top become a 6x instead? Multiply it by 2. So then the top equation will become 6x, take away what? Take away 10y equals what? Equals 6, right? And then now what I need to get the bottom x to become the negative least common multiple. So if I got the top x to become 6x, what do I do to make the bottom x become negative 6x? Multiply by negative 3, correct. So multiply this by negative 3. So then you get negative 3x minus 9y equals 51, I think. Perfect. Now what I'm going to do now, oops, I made a mistake. I forgot to multiply the first one together. So negative 3 times 2 is actually negative 6x, right? It's my fault. By the way, did you hear the news that they have actually been misdiagnosing because of inaccurate tests and inaccurate assumptions? They've been misdiagnosing dyslexia in a lot of people. Because sometimes I've noticed that my brain is already on the next thing when I'm like starting to write things down because like my brain is ahead of me. So sometimes I write things like I forget to write the first part right. And so there actually could be a lot of people who've been misdiagnosed with various symptoms, and they've been realizing that recently. So anyway, so 6x plus negative 6x just goes away, right? And then what about negative 10y plus negative 9y? Negative 19y. And what is 6 plus 51? 57. Then divide by negative 19. And then you get positive y equals negative 3, I think, right? And you can use a calculator on the final. I don't remember if there's a restriction on graphing. I think there is a restriction. So what I'll do is I bought like 8 calculators earlier this year. I can bring them. So you just have to make sure that you just use a scientific calculator. And if you don't have one, I'll bring several extra ones for you. So, because I think that's kind of not fair if you have spent all the money on a big calculator and then you can't use it on the final. But I do want you to have calculators because you have enough stress as it is. So if you have something like 15 divided by negative 7, you don't want to have to worry about that. So you can use a scientific calculator, but not something that can actually like compute solutions for you by itself, like a graphing calculator. So y equals negative 3, and then how do I find x? By the way, one time I had this wonderful student who got everything right on the final except for one question. And it was this question. They did everything right up until this point and they just stopped. So why wouldn't you get credit for it if you just stopped at this point?
Didn't find out X.
You haven't found the other letter, which happens to be x. So you can pick your equation. That I always pick the smallest one. So to me, the smallest one is the first one. We're going to pick the first one, 3x minus 5y. 3x minus 5y equals 3. Except I'm going to take away the y though. So I'm going to take away this y and change that to be equal to negative 3, right? So you'll get 3x minus 5 times negative 3 equals 3. What's negative 5 times negative 3? 15. So you'll get 3x plus 15 equals 3. And now I need to subtract the 15 from both sides. Get 3x equals negative 12. So if you get 3x equals negative 12, what do you do to get x? Divide by 3. So you're going to get x equals negative 4, like that. So do you see how the final is basically fairly straightforward, but there's just so many different things on it. It's really hard to be ready for it if you don't know how to get ready. So that's why I'm spending this whole week doing this review for you. Okay, well now the question number 10. The time required to do a job varies. So whenever it says something varies, that means it has a certain amount of variation, which is called the variation constant. So you're going to begin this whole problem 10 immediately just by saying t equals k. So k is the letter that the book uses to represent the variation constant. So whenever it says something varies or something is proportional, either one, write down that it equals k. So the varies represents the letter K. But what does the word inversely represent? What does the word inversely represent? So inversely represents divided, right? So we're going to say K divided by, and the number of people, P. So that's what you know. It says T equals K over P. That's what that words mean in this equation. And then it tells you some numbers. It says, given that it takes 45 hours is time, and if the people is equal to 8, so we're going to solve that. So T equals 45 and P equals 8, then how much variation is happening? We need to find the K. So put in 45 for T, and put in 8 for P, and you don't know K. So 45 equals K divided by 8. Now we're going to cross multiply the times this 8. What is 45 times 8? 360 equals K, right? So multiply the bottom of the right times the top of the left. And technically also you could say, since 45 is like 45 over 1, you could say you're multiplying the bottom of the left times the top of the right. But 1 times K is just K. So that's, you don't really have to show that step. So we're cross multiplying the two fractions and getting 360 equals K. Now we're going to write down the final equation that solves the whole rest of the problem. So the formula is still true. T always equals K over P. But now we know that T equals K over P actually becomes T equals 360 over P. So that's the formula for the time. From now on, it'll always be 360 over P in this particular problem. So then it asks one final question. How long will it take 9 people to complete the job? So we're going to use that equation. So if T equals 9, not T. If 9 is the people, right? So which letter is the people? It's P. So if P equals 9, then how much time does it take? Well, the time would be 360 over the people, which is 9. And what is 360 divided by 9? 40. So it'd take 40 hours. It would take 40 hours of time for 9 people to do it. Does that make sense? Now, this problem can probably be done in like 10 minutes if you slowly think about the people working, but it's very tricky though. So this problem can sometimes be designed to make your brain really struggle to figure it out, right? So you can try sometimes to figure out in your head based on how fast the people work, but that's a lot harder than it sounds like. So let's do one last problem today. Oh, it's 151, but that's good because this last problem is instant. So remember, ln means log base e, log base e. And so what does a log base e do to the base of e? It just cancels it. So that just cancels, and you just have 5.73. So that's all for today. So next time we will plan on reviewing page 3 and page 4. And by the way, so next Monday, I'm going to give, once I get the real final exam, hopefully it'll be before next Monday. I'm pretty sure it will. So next Monday in class, you'll just be taking the final, but only the first 2 pages of itself. You're going to do question numbers 1 through 11 on the final a week from today in this class, and then you can just get that done with. Keep up the good work, everyone. Good job. See you later.